Welcome to SUSECON Digital 2020. Thank you for joining us today for an overview of containers in high-performance computing with SUSE. My name is Rodolfo Bejarano. Let's get started. We'll begin with a quick recap of what a container is. In short, a container is an image that is layered with all the required packages in order to run an application anywhere. Only requirement is an underlying Linux kernel. They're lightweight and can be deployed. It can deploy your entire stack in seconds without you needing to worry about dependencies. Instead of having to check the requirements for packages A, B, or C that are installed on the guest OS on the VMs on the left side of your screen, you can simply deploy your containers with ease, empowering your operations teams, developers, to focus on things that matters most to your business. You can deploy containers anywhere, regardless of the location, whether it's bare metal, virtual machine, public cloud, or the private cloud, Which container options does SUSE provide for high performance computing? Let's start with Singularity. Singularity, my clicker stopped working. Singularity allows for an untrusted user to run untrusted containers in a trusted way. This makes it one of the most popular open source container technologies for high performance computing workloads. A Singularity container is what it's called a squash FS with a header. It's simply called a CIF image. A CIF image can be created from a Docker container without requiring any manipulation to the file. In order to run a Singularity container, you can simply go to the Open Build Service link that you can see on this presentation and get the packages. Once you've installed it, you can then pull a random Docker container with the command Singularity pull as shown on the example. Your container's location, and then you can finally run it with the Singularity command, Singularity run, and the location of your container. Singularity allows you to run workloads on various GPUs, following industry standards like Kubernetes and the Open Container Initiative. They're designed to perform and run HPC workloads in a secure fashion, allowing you to utilize any workload manager of your choice, like Slurm, or third-party vendors like Univa and others. Another open source technology that is very popular in the HPC world is CharliecLoud. CharliecLoud uses the user namespaces to run containers with no privileged operations or daemons. This simple approach mitigates security risks while maintaining performance and functionality intact. CharliecLoud does not require Docker to run containers, but it also cannot run a Docker container image directly. You will require to run the convert command in order to convert your Docker images into CharliecLoud images. Just like with Singularity, you first require the CharliecLoud packages from the Open Build Service on the link shown in this presentation. Then you can pull the Docker image and flatten it with the chdocker to tar command. This will create a tarball, a compressed tarball of your container. This tarball can be copied over to other systems for use by CharliecLoud. You then will simply require to decompress the tarball into a directory of your choice with the command chtar to dir. Finally, you can run your newly decompressed container with the command chrun, and you'll be back at your host system. Where does SUSE fit in the HPC world? While the SUSE HPC product has been around for years, and I didn't know this one built, but there we go. While the SUSE HPC product has been around for years, it seems that this is one of the most least understood products that we have in our portfolio, mainly because this version of the operating system has been sold through hardware partners and embedded, for example, with Cray. But the HPC market is changing, with opportunities in every sector and environment outside the traditional scientific supercomputers. The HPC module within SLES provides a fully vetted package suite for HPC workloads. We do support technologies like Kubernetes, as well as work together with GPU vendors like NVIDIA, and we are part of the Open ACC initiative, which allows for better use of the accelerators. SUSE's involvement in HPC space goes from providing packages on Singularity containers to TensorFlow for machine learning, as well as providing workload managers like Slurm, plus the option of running your workloads on the public cloud, as mentioned before. Also, ARM processors are getting a lot of attention recently with the involvement of Cray, HPE, Cavian Marvell chassis that we are using to utilize the ARM processor. High-performance artificial intelligence powered by containers is a very trendy thing now on HPC, just because HPC provides those containers the ability to transfer small files in a hyperscale environment through the PCI bus, making it extremely efficient. Now to cast the players. As mentioned before, we provide the HPC module with a variety of HPC applications and packages like Slurm, Singularity, Robinhood. SUSE relies on its partnership with other vendors to be successful. So we're deeply embedded with them in working with various workload managers from third-party vendors like Bright Technologies, Univa, Altair. Additionally, we've been working alongside Sci Labs, to get support for the Singularity containers that we discussed today. I have gathered a list of links and resources for you to go and check after this presentation if you'd like additional information on how SUSE plays in the HPC world. So again, thank you for your time. I hope you enjoy the new digital experience at SUSECON Digital 2020, and be sure to check out other sessions for amazing content.